Our next lab is about electric circuit, and we will be experimentally verifying Ohm's law. Ohm's law is the basic of electric circuits. It establishes the relationship between voltage, current, and resistance for any electrical circuit. In order to complete the circuit, we will need at least energy source, for example battery, conductor wires to connect one component to other component, and our resistance, for example a light bulb. And Ohm's law is what establishes the relationship between these components, namely voltage, electric current, in these parameters, namely voltage or electric potential, current, electric current, and resistance. And according to Ohm's law, the current flowing through a conductor is directly proportional to the voltage across it, and it is inversely proportional to the resistance. Mathematically, B is equals to IR, or we can also write it as B is equals to I is equals to V over R, where V is the potential difference. We also call it voltage. I is electric current, R is resistance, and the unit of electric potential is voltage, current is ampere, and resistance is ohm. And and an ohmic resistor is a resistor, or is a resistance which remains constant over a range of applied voltage. For what it means is, even if we change the voltage from low voltage to high voltage, the resistance of the material will remains the same. And this Ohm's law basically establishes the relation uh, between the voltage and resistance. So if we have a experimental setup such that we can change uh, the voltage for a certain resistance, it will automatically it will change the current, meaning what I'm trying to say is, if we record electric current as a dependent variable based on the voltage, we can create a linear graph between voltage and electric current, and calculate the resistance using uh, these relations. So if you look at this relation, so this is basically slope intercept form without a intercept part, right? So if that's the case, if we draw a voltage versus current graph and calculate the slope of that graph, the slope of the voltage versus current graph will give us the resistance of the circuit. So that's how we can verify experimentally. We can verify the Ohm's law. So the first part, again we will use the simulation from FET website. The link is provided here. If you click on the link and go here, you get this is your home page, and click on lab. And then once you go in lab here, first let's look at different let's look at the user interface. Here we can, in the left we can see wires, batteries, light bulbs, different components. And in the right we have different tools, ammeters, voltmeters. We use voltmeters to calculate to measure the voltage, and ammeter to measure the current. And there are few more settings here in advanced. If you click on here, So what you can do is you can change the resistivity of the wire, or you can also change the battery resistance. For this lab we are only interested in wire resistivity. For the first part we will leave the wire resistivity to tiny. Basically the wire has very negligible resistance. So the first part is verifying Ohm's law. So what we will do is we will create a series circuit between a resistor, emitter, and a power source, namely a battery. So we can see the basic series circuit here. As we it, whenever we are generating whenever we are creating a basic electric circuit and we want to calculate the current flowing through the circuit, the ammeter is always connected in series, and the voltage or the voltmeter is always connected in parallel with the component you want to measure the potential difference across, right? So this is an example, a basic uh, series circuit with which we will use to verify the Ohm's law. So how we can do is we can go here. So if you click and drag these components, you can just click and drag these components from there. So like this. So this is wire, and we can also bring a resistor here like this. And in order to connect them, if you see here this circle at the end, these are the connections. So if you drop here and let them snap, it's basically saying they are connected. And if you want to disconnect it again, please click here, and then you can also delete it, or you can cut it from the connection and bring it back. So if you want to take it again here like this, so basically what we have here, we have a resistor and two wires connecting each end of the resistor. So like I just said before, whenever we want to measure the current in the circuit, we want the ammeter in series. So like this, this is in series. Now we want to connect the battery. Like this. Now we can see here the electron is flowing in the circuit, meaning the circuit is closed, and it will be easier for us to see the direction of current flow instead of electron flowing. So we can click here in conventional here. And also if you click on values, it will show the resistor, what the voltage is and everything. I recommend you to click on the values here. And if you read the instruction here, what it's saying is keep the resistance to 80 ohm, and basically we will be changing voltage from 20 volt to 120 volt, and measure all this, record all the current with respect to the change in voltage, and you will use this voltage and current to calculate the resistance in the circuit. Basically what we are trying to do is, we already know the resistance of this circuit, but we will also want to calculate the circuit, calculate the resistance of the whole circuit. And one thing you need to remember is, for the first part, just leave this wire resistivity to low or tiny, and for the second part we will increase the resistance of this wire, as we can see here. as I'm reducing the resistance, sorry, as I am increasing the resistance, the amount of current flow is also decreasing. So we will study this relation in the second part. For the first part, we will just leave we will just keep the wire as negligible resistance. So once you have it, take this voltmeter and then uh, in use these probes at each end, each terminal of the resistor. Now we can see the voltage on the uh, across the resistor, and current here, and the source voltage is here. So basically you will do repeat this test for multiple uh, multiple voltage, and then draw uh, resistance sorry voltage versus, then you will plot a voltage versus current graph here, uh, and then you will create a best fit line with approximately which is uh, approximately the best fit line for the whole V versus I points, and then you will establish a linear relationship and calculate the slope of that best fit line, and that slope will give us the resistance of the resistor, which if you do it is if everything is correct, should be equivalent to 80 ohm. Now the first part is pretty straightforward because there's only one resistance 80 ohm here, and with sorry oh, before that, I want to let you know that you can change the resistance by just clicking. If you click in this resistor, it will open this slider. So you can just move this slider around to change the resistance. Similarly, you can also change the voltage like this. So for the second part, what you have to do is, instead of leaving this resistance on the wire as negligible, we will have some resistance on the wire, and we will calculate the resistance on this wire using this relation. So basically we will calculate, we will use the same process, similar process. We will keep the in this case we will keep the voltage constant and change the resistance from 10, 20, 30, 40 and so on, and we will also record the current in the circuit similar to this. Basically what we do is, first you will start from for example, let's say 10 ohm, then you will record a voltage 31.97, current 3.2, then you will increase the current to sorry voltage to some other value, then read the voltage and current and so on. You will repeat it for 8 different values and use that to calculate the overall resistance of this overall resistance of this whole circuit. And once you do that, we already know the resistance of this resistor we are using in each case. So basically if you subtract this resistor from the overall resistance or the total resistance, we can calculate the resistance flowing through resistance of this uh, electric wire. Similarly, we can do the similar process to calculate the resistance in battery if you want to. For example, let's say there's an internal resistance in the battery, then we can also follow the similar process to calculate the resistance on battery. And that's pretty much the everything for this lab. So basically we will verify the Ohm's law using a simple series circuit where we will change the uh, where we will change the voltage in the circuit, keeping the resistance constant, and then record current, calculate the resistance, and plot the voltage versus current graph and calculate the slope of the graph to verify if the resistance is if the slope is same as the resistance you initially set up. For the second part, using the same principle, we will calculate the resistance of the we will first calculate the overall resistance of the circuit, and using the total resistance and the non-resistance of the resistor, we will calculate the resistance of the wires we are using in the circuit.